Good afternoon, everyone. I'm really happy to be here in Singapore. It's my first time here. It's been amazing so far. So I'm a senior data scientist at Magento in our office in Austin, Texas. And I work closely with our colleagues at Adobe Research in the Bay Area. So I'm constantly between the two areas. Today, we're going to talk about applications of machine learning in e-commerce, specifically use cases that are of interest to Magento. So a little side note, the term machine learning. So loosely speaking, we'll be, right now we'll be interchanging the terms machine learning, artificial intelligence, data scientists, data science, liberally, although they're not exactly the same. You can think of machine learning as a subfield of the broader artificial intelligence. But usually when we hear the term AI or artificial intelligence, we're almost certainly referring to machine learning, which is the mathematical field where you train a machine or a computer program to learn from data and then to eventually act on that learning. Maybe we can scroll down to the second slide. All right. So now that Magento is a part of Adobe, I wanted to highlight 3 points that make us the 3 advantages of being a part of Adobe and position us for differentiation in the e-commerce space. The first is that Adobe is very well known for its creative legacy. You can think of the work they've done around design, UX, multimedia. And that can only serve to enhance the way we use this information to enhance our customer experience. Then the second big thing about being a part of Adobe is the fact that their content management system is one of the most popular systems that we have, and their data platform where bringing in that data can only serve to enhance the picture that we have around the shoppers on our e-commerce platform. In machine learning, data is really the name of the game. So almost always more data is better when it comes to machine learning algorithms. Let's go back to the yes. And then finally, the third point that I want to highlight is now that we're part of Adobe, we have access to a wealth of cutting-edge research that Adobe is doing through their research lab, and we're very much connected to that. All right. So the field of machine learning is really broad, and I wanted to categorize it here into 5 broad categories. This is not by any means a standard categorization. There's many ways to break up the field. Today we're going to briefly describe and touch upon those categories, and then we're going to dive a little bit deeper into recommendation systems, which is an area that my team right now is focusing on heavily. All right, so that said, I wanted to show here that we really are sitting on a wealth of opportunity at Magento. Anywhere where there's data in the platform, whether it's the core platform, whether it's applications that work well with Magento, like Magento Order Management or Magento Business Intelligence, or extensions that plug into Magento, wherever there's data, then there's an opportunity for us to use that data, to leverage it in order to enhance our customer experiences, to drive customer insights, and even to help us do smarter measurements. In order to understand how well we're doing, essentially. All right. Okay. So the program for the rest of the talk is really 2 things. The first thing we're going to do after the slide is briefly list some examples of use cases that fall into one of those 5 categories that I had listed previously. And then the rest of the talk will be on recommendation systems. Okay. So the first category I had listed up there is natural language processing. Each one of those subfields in machine learning is of its own a field that merits, its attention, and we have expertise in each one of those fields alone. And so the first thing that is highly valuable to us is applications of the research that we've done around natural language processing. So anywhere where we have text, where we have speech, is an opportunity for us to apply techniques from NLP. And examples of that include things like conversational AI, where you speak to your Alexa at home and ask her to give you suggestions for what to eat for breakfast. Things around summarization. So for example, if you have a whole video, but you really want to surface the main highlights of what's in that movie, for example, we have things like, this is video summarization, but you can do the same for documents and document summarization. Things around semantic search. For example, you type in Apple, do you mean the apple that you eat, or do you mean Apple the company, and so on and so forth. So obviously, an important example for us is customer reviews. Oftentimes, our products or the products of our merchants have a ton of reviews associated with them. How do we summarize this information? How do we get a general idea of what the sentiment is that is associated with each one of those products as a result of those reviews? And this is an example of where we use NLP to do sentiment analysis to understand what the general sentiment of a text actually is. Right? The other big field that I had listed up there, that's the second category, is computer vision. And you can think of computer vision as the analysis, the machine learning, the prediction, the modeling that's associated with images and videos, and other modalities like 3D or VR and whatnot. So examples of applications of computer vision include things like object recognition, face recognition, content understanding, even things around image aesthetics and image quality. What else do I have up there? And things around visual search, where let's say I'm a merchant and I want to enable my shoppers to not only search by typing in what they're looking for, but rather search by, say, inputting an image that they took of, a celebrity wearing something that they found appealing, and they want to look for something similar. All right. This is an example of what I was talking about in visual search, where for instance, over here on the left-hand side, you have a picture of a nice living room, and then essentially you want to be able to recreate something like that. You want to see whether a merchant's catalog has some of those items that you think are appealing in the picture. And this is just an example of, you input this image, and the algorithm recognizes the different objects within the image, and then retrieves those objects, and then uses those as a search query into the image catalog that a merchant might have uploaded. Okay. Another example in computer vision that I alluded to earlier is image aesthetics. So for instance, a catalog might have many, many images. How do you pick the best images to surface first when a shopper searches for something on the internet? So what images might appeal more to the customers from your list of images associated with one particular product? So there's been a ton of research on understanding what appeals to humans when they look at an image or a video, for that matter. And there are cultural differences as well, and it's always interesting to try to model these. The research is there. Now the idea is actually using that within an e-commerce platform to enhance a customer's experience. The third category I had up there I skipped recommendation systems. That was the fourth category, but we'll come to recommendation systems in the end. Causal modeling and explainability is another really important and really, really challenging area in machine learning. Whereas we typically are able to sense and understand causality. So you see a particular trend and you see that it's associated with something else. That's correlation, but that doesn't necessarily mean that one is causing the other. Causality is an area of research where we really try to understand what causes a particular effect, an action, a trend to be happening. This is a very active area of research, but one that might enable us to understand, for example, what drives a particular customer or a segment of customers to behave in a particular way when they come to a website. Right, our fourth category is reinforcement learning. A very active area of research at this point as well, in addition to causality. So let me briefly describe what reinforcement learning means. But just a show of hands here, what's the level of, who in the audience is familiar with this subfield? Okay, great. Very briefly, in machine learning, you have an algorithm or a program, and that algorithm, you for a certain period of time, you feed it data, it learns from the data, and then you go and you deploy it in the wild, and it makes predictions. In reinforcement learning, instead of actually having a training period where you train an algorithm and then deploy it, you have a basic skeleton of an algorithm, and then essentially you deploy it in the wild, and it learns as it goes. So the more data it sees, the more it morphs and learns and becomes better and better at predicting what a user actually wants. So one is called supervised learning and one is called reinforcement learning. And it really depends on what is available to you. So you don't always have the data, and so you can deploy and then learn as you go. Yeah, but oftentimes there are uses for supervised learning that, for example, in computer vision, you do want to train, you do want to tell the machine that's a cat, learn that this is a cat. I'm going to show you 1 million images of cats, and now whenever you see an image, you're able to tell that it's a cat. So it's different use cases. And one of the places where reinforcement learning is now starting to be used is in testing. So we're familiar with A/B tests, right? So in A/B tests, we split the traffic, and then for a period of time, we direct. For group A and for group B, we show them 2 different experiences, and then after a while, we come back and we see which one is better, which one caused more conversion. But we've wasted some resources. We might have wasted some resources. So if group A is not doing so well, I'm still running the test for a certain fixed period of time. In reinforcement learning, we can slowly start to direct the traffic more and more towards the group that's doing better. So you have better management of resources. Next slide. I'm going to skip this one. We're familiar with things like predicting demand, customer segmentation. I'm just going to skip it in the interest of time. And for the remainder of this talk, I want to talk about the subject of recommendation systems that I'm very, very passionate about. And, we have all, consumed the outputs of recommendation systems, and we do this every day when we're streaming music, when we're trying to shop online, or when we're trying to pick what to watch on platforms like Netflix. And it's been shown that recommender systems actually are very lucrative to the companies that use them. So, for instance, more than 80% of Netflix movies are recommended to a user. These are not movies that the user actually went to the platform and searched for specifically. All right, so with that said, I want to take a small digression And let you know, so recommendation systems, they learn from previous data. And then, they learn from data that they've seen in the wild, and then they model, they run a model, and then they assume that there's certain logical assumptions about humans. So if a lot of humans like this particular thing, you might like it as well. Humans are not always logical, and honestly, we're a mess. So let me do a little experiment to show you some of the cutting-edge research that we're starting to do at Adobe and Magento. So this is a small experiment I'm going to run. There are two gambling strategies here: gambling strategy A and gambling strategy B. And we're going to see which one you prefer. So in gambling strategy A, you have a 100% chance of winning $1 million. In gambling strategy B, you have 89% chance of winning $1 million, 1% chance of winning nothing, and 10% chance of winning $5 million. I want a show of hands. Who prefers to gamble using gambling strategy A? Raise your hands. Okay. Don't be shy. Can I ask again? I mean, it's fine if you don't like it. And who prefers strategy B? Raise of hands. Okay, great. Who prefers strategy A? Just show me again so I can... Okay, I think we need a count. Anyway, usually, I saw that it was pretty balanced, which is weird. Okay? Usually, the majority goes with strategy A. And I think there was a little more of A, but I was just surprised that there were so many Bs. You're using reverse psychology on me. So I'll show you in a second. So experiment 2. The A strategy is 89% chance you win nothing and 11% chance you win $1 million. Gambling strategy B, 90% chance you win nothing, but then there's a 10% chance that you win $5 million. Okay, look at it a little bit. Decide on which one you like better. For those who like gambling strategy A, please raise your hands. 1, 2, maybe. Okay. And for those who like strategy B, please raise your hands. Yes, it works every time. All right. All right, next slide. Sorry, Hand. I'm almost done, Hanjun, so. All right, usually, and we confirmed to me that you like strategy B. I'm very happy. Let's skip 2 slides. So this is just what I showed you. I put them next to each other. Okay, one more slide. One more slide, Hanjun. Yep, great. Okay, so now what I'm going to do is I'm going to show you something very, very simple. I'm just going to split this box. So this is $1 million, 100% chance. I'm going to split it into $1 million, 89% chance, or $1 million, 11% chance. I really didn't change anything. Right, so I just rewrote gambling strategy 1A into this. This we're going to keep the same, and then this we're going to keep the same. Well, no, this we're going to split 2B into 89% chance you win nothing, 1% chance you win nothing. And then we're going to keep this last thing the same, right? Didn't change anything. I just rewrote a simple like change of the way I'm writing this. Now notice we're comparing 1A to 1B. 1 million, 89. 1 million, 89% chance. Same thing. We're good. In the second experiment, we have nothing for 89% chance, nothing for 89% chance. So here, if I scratch these out, I can do that, right? Because I'm just comparing 2A to 2B, and these are the same. I can also scratch this and this, because they're the same. Next slide. Okay, so I'm just scratching it out. Notice something here. 1 million, 11%, nothing 1, 5, 10. 1 million, 11%, nothing 1, 5, 10. These were the same exact choices in expectation. Yet, it's a paradox. This is called the LA paradox. The way I presented you the information in the first experiment, the majority of you picked A. And the way I presented to you the same thing, the majority of you picked B. All right. This is my last slide. I was trying to make a point with the experiment, and the point is that we have something which is called cognitive bias. And cognitive bias is a deviation from logical expected behavior that is systematic. And what we saw above is an example of cognitive bias that is called risk aversion. People usually don't like risk so much, but then they'll take risks if the chances of winning something really big is there. So they'll do it. But we really hate risk in general. So that's one example of the many cognitive biases that we have. It's a fascinating field. How does this relate to recommendation systems? So current recommendation systems don't account for human cognitive bias. And there's a lot of biases that are actually very relevant to e-commerce, and they're used in marketing strategies, but they're not used in current recommendation systems. This is very, very cutting-edge research that we've started to do with the Adobe Research team. Not in recommendation systems. Yeah. The question was, do current recommendation systems take into account human cognitive bias when they model human behavior? So they don't. Okay? So this is sort of the evolution of recommendation systems. It's an evolution more in the research field. In practice, usually these three categories are deployed in practice. These are really not. These are very, very new. Cognitive bias is super, super, super new. I'm not aware of people doing that other than our research team. There might be, but to the best of my ability, my knowledge. Usually we use things like item-to-item similarity. So we learn that items are similar to each other because they're bought by similar groups of people. So if you buy A, B, C, and somebody else buys A, B, and C, we assume that there's a similarity between those items. Content-based methods are a bit more sort of specific because every single item in the catalog, for example, has to have metadata that describes what it is. It's pants, it's for winter, it is. So it requires a little bit more of having metadata to characterize what those items are, and then using this metadata in order to understand what items are similar to each other, and use this information to make a recommendation when somebody buys an item. Then I can recommend items within that category of similar items which I've derived from the data. Context-aware methods are methods that take into account things like what time of the year is it, what's the weather today, things around where is it deployed, in what region. So it also needs that metadata to understand the context. And then the last two, which we're investing in doing a lot of research in at Magento and Adobe in general. One is the temporally aware contextual and contextually aware recommendation systems, where you don't just want to maximize clicks on a product right now. When I recommend a product to you, I want you to click on it, yes. But this is an instantaneous optimization. I want to maximize the likelihood of you clicking on the product now. But a temporally aware recommendation system tries to maximize the lifetime value of a shopper. So I want you to click on it now, but I also want you to come back to the website and come back again, and so on. Maybe if you click on it now, you might not come back later. Just trying to do the optimization over a longer period of time than an instantaneous optimization. And then finally, the cognitive bias aware methods that account for our quirks, our cognitive quirks in that sense. And then the last concluding remarks, thanks. So, we briefly talked about, applications of the different subfields of machine learning. We've talked about that. Well, recommendation systems, the point I wanted to make is that even though they're ubiquitous and we use them every day, there's still a long way to go in terms of, getting the most out of them. And then finally, we have an early access program where some of our merchants have agreed to sign up with us for early access to those cutting-edge experimental algorithms. So if we have merchants here that are interested in that, please talk to me afterwards. We always love to, as researchers, we always love to work with our merchants and, see what funky things we can do with them. Thank you.